Welcome back to day one. We got part two on standby here. So we just talked about how you can find missing angles when you're given angles both inside and outside a triangle, both convex and concave. These are concave angles when they're facing out. Now we're going to throw it back to ratios. So we know when we deal with ratios, a lot of times ratios involve an algebra problem with a common variable. So when we deal with ratios, guys, a lot of times that means we're dealing with an algebra problem with a common variable. So for example, we're told the ratio of the angles of a triangle is 3, 5, and 8, or 3, 5, and 8. So get a triangle like this. Okay. So 3, 5, and 8. I'm sorry. We'll put that up there since this looks like the bigger angle. Now here's the thing. That's not what these angles are. That's the ratio. So here's where we use a common variable. We'll go 3x, 8x, and 5x. So this is our ratio here. We know that 8x, 3x, and 5x, this is going to be our biggest angle, that's going to be our second biggest, and that's going to be our third biggest. So we're going to find each angle and then classify the triangle based off the potential sides and angle measures. So here's what we have to think about. We've got our ratios. What do we know about the total degrees inside a triangle? We know all adds up to 180. So that means this ratio, 3x plus 5x plus 8x, should all add up to be 180 degrees. Whatever this angle is, whatever this angle is, and whatever this angle is. So I'm going to give you guys a chance. See if you can solve for x. Go ahead and solve this for x, guys. See what you get. Okay, we add combined like terms, you get 16x divided by 16, you get 11.25. Now that's not our final answer, but this now is what we know is our common variable that this ratio shares. So take that and plug it back in. So now we do 3 times 11.25. We know this is going to be 33.75 degrees right there. 5 times 11.25 gives us 56.25 degrees there. And then 8 times 11.25, hey, we get a 90-degree angle right here. Turns out this is a right angle. Okay, so because of that, we now know we have a right triangle. And do we have anything else? Well, if it's right, this angle's different, this angle's different, this angle's different. If all the angles are different, all the sides are going to be different. This is also a scalene triangle. So we found our angles, and we classified it based off those angles and the potential sides they would give us. A right triangle that's also scalene. Okay. Let's do one more together. One more like this. I'll set it up, or at least help you guys set it up, and then I'm going to let you take over from there. So let's look at number 2. So I'm gonna zoom a little bit in here. There we go. So we know the ratio of the measure of the acute angles of they went ahead and told us it's a right triangle, is 4, 5. So all we have to do here, since we know it's a right triangle, find the measures of these acute angles. So we're going to try and find our missing angles here. But the good news is, we know that we have a right angle. So we've already got that one. Where do you guys think this 4 and 5 belongs with? Oh, yeah. this angle, and this angle. And again, we'll use x for our common variable for the ratio. Because again, we got a ratio. So I'll call this 4x, and I guess this will be 5x. And so what do we know all these angles have to add up to be? Well, just like last time, it all adds up to 180. So, but this time we actually know an angle, 90 degrees plus 4x plus 5x. That's all going to add up to 180. And now that we've set this up, guys, let's see if you can solve for x and then find our two missing angles. I'm going to see if you can finish this problem. Go ahead and give it your best shot, guys. Now that we've set it up, see if you can find our two missing angles. Okay, so we would subtract 90 over. It gives you 90 equals 9x. Divide by 9, we get x equals 10. But again, that's not our answer. We want to find the measure of these acute angles, these angles smaller than 90. So we take 10, plug it into our ratio. We get 40 degrees for this angle and 50 degrees for that angle. So if you need to, you can pause, take a quick breather, and when you're ready, we'll jump into our last page. All right, so on to page 3, our last page before our homework. We're going to hop over number 3. If you want to see how to do this one, I've posted the scan of the day. And so if you want to get in here and see how to do this one, it's pretty similar to the other two. The main thing is we set up a variable for an angle, and then both of our other angles, z and y, are based off their relationship to x. So you set up kind of two expressions for z, or one for z, one for y, add z, y, and x all up to 180 and solve. And you can see that if you need to on the scan attached to this day. But the last thing we're going to do with triangles here, this is going to be kind of tricky. I'm not going to lie to you. It's going to be a little bit tricky here. So let's take it one at a time, guys. So we're going to name the missing coordinates. The problem is some of these coordinates, we won't know exact. We're going to have to just come up kind of with our own distances. If we don't know, we won't know the exact. So I think that may end up happening here on number 1. Let's take a look, guys. So we got a right triangle. Okay. Now, as far as what M is going to be, obviously, point M, it's on the y-axis. So this is a y-intercept. So we know x is going to be, very clearly, we know the x is going to be 0 because we're actually on the y-axis. Now, for the y, this is kind of the tough part, guys, because we don't know that this side is the same as that side, and we obviously know this side's going to be big. That's our hypotenuse. We don't know. This is a right triangle, but along with this side being different, we have to assume that all three sides are going to be different. So we get to make up. We're going to make up a height. We just don't know. So if this is 0 to 3b, we don't know that. I'm just going to call this c. We got a distance of c up. Yeah, we didn't know. We just made that up there because we had no reference to tell us what the y was going to be there. So 0c. We didn't know the x. How about number 2? This one, we got a little bit more information. Number 2, I'm liking. So we got 0, 0. Let me see, we go up to that point. Okay. Oh, check it out. This piece and this piece are the same. So if we're at 2a, from there to there is 2a, then wouldn't it make sense that from there over to here would be 2a also? Yeah, so that means this is going to be 4a. And check it out, if this is b, That's how high up we are. Obviously, the good news is we don't have to worry about that because where is Q? Oh, it's on the x-axis. If you have a point on the x-axis, it'll be 0. So we used the fact that we knew we were 2a along the x-axis here, and these two pieces were congruent. So this was half, that was half, half plus half gives you the whole, 4a. Let's look at number 3. Okay, so we know, hey, this piece and this piece are congruent, going to be the same. So we went from 0, okay, this is a distance of 2a. From 0 to 2a, that's 2a difference, which means that's also going to be 2a. The tricky part is this is on the y-axis. So we went 2a up on the y-axis. We know x is going to be 0. That 2a applies to the y. So 0, 2a would be a here. And then I want to give you guys a chance. See if you can try this last one for me. Try number 4. Let's see how you guys do. Okay. So hopefully one of the first things you guys noticed was this is a equilateral triangle. All 3 sides are the same. So we were told that along the x-axis, to get from x to y, we went 2b. Well, if this is 2b, and we know that's going to get us 2b, then wouldn't it make sense that then this would be b to b, b to b, kind of the halfway point? So then on the x-axis, we know z is going to be b. So we know we went b over on the x-axis to get to point z. Here's the problem, though. Our height is not going to be 2b. That's not right, because this height is slanted. So the problem is we can't tell. So this height is slanted. To get from there up to here, it's not straight vertical. Our height is slanted, so we have to make up a height. We don't know a height, so we make it up. I'm going to call it, let's go C. So we were able to find our x, but as far as our y, we had to make it up. So I know those are a little bit tricky, guys, but hopefully you had some fun with those. I kind of like those. Those are like little brain teasers. And so we're going to end today. Last thing, if I give you a little bit of H-dub for multiple choice, it's funny, we're in chapter 5. Last year, this was Algebra 1. We did this last year in chapter 5 of Algebra 1, if you remember that. Solving systems. There are 2 ways to do this, guys. You can either use substitution, or we can use elimination. And here's how you know. We use substitution when we have variable by itself. So when you have a variable by itself, substitution is a great method. We use elimination when the variables are lined up. So when the variables are lined up, check it out, x over x, y over y, number over number. When that happens, elimination is a great option. So a little throwback action here. With substitution, we know, and guys, if you already know, you can pause and try it yourself. But we know x is going to equal 2y plus 3. Well then, if this x equals 2y plus 3, we can substitute that in for that x. So we've really got 2y plus 3 minus 5y equals 9. See what we did there? We took 2y plus 3, plugged it in. Oh, and don't forget, what's in front of that x? Boom, a 4. So 4 times not x, but 2y plus 3 minus 5y equals 9. And from here, guys, it's just a straight up algebra problem. We know how to solve this. Distributes, combine like terms, subtract that 12 over. 8y and negative 5y gives you 3y. Subtract 12 over, 9 minus 12 gives you negative 3. And then when you divide negative 3 by 3, y equals negative 1. Now, are we done? We solved this for y. We got it. No, but the good thing is we did the toughest part just now. You take that answer, we're going to plug that back into the top because the top's already set up for us to find x. So x equals 2 times y is negative 1 plus 3. 2 times negative 1 is negative 2 plus 3, positive 1. So in other words, these two lines intersect. These two lines intersect at 1, negative 1. That would be the equation, the solution, the point where these two lines cross. Now I'm going to get number 2 started, and then I'm going to let you guys finish here. So hey, check this out. These are set up perfectly to eliminate. So when we eliminate, we add this equation with this equation, kind of down the line. So x plus 3x, 4x, and here's what we call it elimination. 7y plus negative 7y cancels, equals 16 plus 4. That gives you 20. Hey, I love elimination. Divide by 4, x equals 5. The only problem with elimination is the tough part comes second. Because now that we know x, we either need to plug it into the top or plug it into the bottom. Which one would you guys like to do? Pick the easiest. I'm thinking plugging that back into the top. So 5 plus 7y equals 16. And I'm going to let you guys see if you can take this the rest of the way. See if you can finish. So when you work this out, subtract 5 and divide by 7, did you get a fraction? Good. So y is going to be 11 over 7. X is going to be 5. So the point where these two lines intersect is at 5, 11 over 7. And so guys, your homework, HW is going to be for Friday. Hopefully you don't have to do this over the weekend. It's going to be practice multiple choice, all of page 4. That is 7 multiple choice questions. And we'll see if we can have some fun and maybe do a quizzes or cover this on Monday. So I'll see you guys soon.